So in this video we're going to look at finding the polarity of the coil of windings for an 8-wire stepper motor. So with the 8-wire stepper motor you basically have two pairs of coils. You have pair A and pair B, and so these can be wired in either parallel or series wirings, or they can be wired together as a like a unipolar stepper. And so in this case we're gonna be wiring them in series, but what you have to do is you have to know number one, what leads are what. So a coil is going to have two leads, and it also there's a polarity that goes with that, because if you put current in, you're going to have say we have a clockwise current flowing through this coil, and that would generate a magnetic field with the north pole in the up direction. And so when we put its pair in there, we need to make sure that the polarity matches that. Okay, because if we join them together and the polarities are opposite, then what's going to happen is, like, the top part of the coil will generate the north pole going down and the other coil will have it going up, or vice versa. But anyhow, so basically the fields will cancel and you'll have nothing. So you have to know not only what two wires are for the coil, but what polarity those need to be. And so you need to get the polarity of those correct also. So what we have here is an 8-wire coil or 8-wire stepper motor. So I have here this little stepper motor, and it has 8 separate wires. So what I'm going to do is I'm going to take my oscilloscope lead, which barely reaches here, but I'm going to attach, and I'm just going to pick the red wire and attach the one lead to the red wire, and then I'm going to attach the ground to one of the other leads. And at this point I don't know what leads are what, because I don't have a manual for this motor, so I don't know what they are. But so I'm going to connect, say, to the yellow one. And then what I'm going to do is I'm going to go over to my oscilloscope, and so here's the oscilloscope. I'm going to use the VirtualBench for this. And the first thing I'm going to do is I'm just going to put this in auto mode, and I'm going to set the time division to about 20 milliseconds. And I'm going to set the voltage for channel 1. I'm going to turn channel 2 off for the moment and just take channel 1. And I'm going to set it to about half a volt. And then I'm going to take my motor, and I'm just going to spin the axis and see whether I generate anything. And you can see there's some waviness in there, which is just, I don't know, noise it's picking up or something, but there's no change in that. So as I move this, if we look over here, make this a little bit larger, so as I move this motor, you see nothing happening there. So those two wires that I've got wired up are not a coil. So I'm going to move this to another wire, and I've got 6 other wires to choose from here. I'm going to move it to another one, and I've done this before, so I think this is the right one. And so I'm going to connect it to another one. So I got the red one connected to one, and the gray one connected to one. And I'm going to move that, and yeah, that didn't do anything. So let me connect to this other gray wire. You just need to keep track until you find which one's which, and just keep changing wires till you get something happening. Alright, so once we get a valid coil, you can see as I just rotate the motor. So I'm just manually rotating this shaft back and forth, and I'm getting some waveforms injected in there. So now that's one coil, and I can go through that and do that for all the other coils. And now I need to find the polarity of those coils. So once I mark that, I'll find the polarity. So to do that, what we're going to do is go into single mode so we can capture a waveform. So this is the trigger. So when you're in single, you're working off of this trigger. So you have what's called a trigger level. And your trigger level, you see all these spikes here? That's just due to the noise. You need to make sure that your trigger is above the noise. And so, you know, somewhere for this, it seems like 300 to 600 millivolts is a good range for this. Remember, we're set to each division is about 500 millivolts, and my time division is set to 20 milliseconds here. And so we click on single, the trace goes away, but it's waiting for the trigger. So now when I move the motor, I get this waveform. And so this is my injected waveform, and you know, it's going to kind of look weird because number one, it's a stepper motor, and number two, I'm not moving it at constant speed. So, you know, it's not a perfect sine wave, but it's an injected waveform there. So notice now it went into stop mode because it's just holding that, and we want that because it'll be easier to tell. Because if it wasn't, if I just had it in auto, once I stopped moving it, it would just go back to basically a straight line again. So I'm going to, so now I'm going to wire up two other wires to another coil. So I've already identified two more wires that I know are a coil, and I'm going to attach those. So I've attached another coil. I'm going to turn on channel 2. So I've attached channel 2 to another coil, and I'm going to go to single mode, and I'm going to spin my motor. And now what you see is you see that the yellow is 180 degrees out of phase with the red. Okay, so the yellow is 180 degrees out of phase. So this tells me two things. Number one, it tells me that the coils are part of the same pair. So I've got the same pair, but I have my polarities backwards. They're going in opposite directions. Okay, so what I'm going to do is just flip the leads on channel 2 the other direction. Okay, so we need to mark these and keep track of which one we have. And I'm going to just mark this in the other direction. I'm going to hit single again, and I'm going to spin my motor, and now you can see the two are right on top of each other. Okay, so that means that they're in phase with each other, so that the magnetic fields are going to work together, not oppose each other. All right, so just to show you, if we had the other pair, one of the other, the pair B, I'll connect that, and that'll be 90 degrees out of phase. Okay. So I'm going to flip that over to this wire here, and you know, depending on the polarity, it'd be plus or minus 90-degree phase shift, but we'll connect this up. And I'm going to hit single, and then I'm going to spin my motor. And so here you can see it's not 180 degrees, right? You see, like, here's a hump, and then here's a hump over here. So this is a 90-degree phase angle, and you can see the polarity here. The yellow is actually ahead of the red, so that's a plus 90-degree phase shift. So that is one of the coils on the B pair of your motor. Okay, so we have, again, like on the left here in the vertical, we have pair A, and then we have pair B. And so this is how we can identify our 4 different coils for a 8-wire motor.